Motorcycle seat pans seldom live to a ripe old age. Covers split and expose cushion foam which, like any sponge, has a considerable capacity for rainwater. Our Model 50's original saddle had long since been replaced by a small Suzuki seat. Oh, the disgrace, being rescued from oblivion with a transplant donated by a conquering rival. The Panther Grand Sports has a lifting loop to assist in raising to its stand. This part, fortunately reused by the repairer, also forms the seat's rather awkward attachment to the frame via down-facing brackets, which disappear through slots in the rear parrot beak tub. Ever helpful members of the Owners Club provided pictures and notes to give me a general shape of the original pan, including those with rulers to provide some hard information on bracket positions. I drew out the plan on a grid, halved it for symmetry, and built a cartridge paper mock-up. Guess who got electric scissors for Christmas? With this CAD model, that's cardboard aided design as one subscriber pointed out, I could assess, adjust and trim before dismantling and transferring the patterns to 2mm 15 gauge cold rolled steel, a bit thicker than the original to compensate for a lack of pressed in ribs. The plasma cutter makes short work of creating blanks. And as with setting up for a weld run, it's advisable to mime your moves to make sure that you have the space to run a cut unimpeded by the bench or your body parts. Enjoy the show. My felt marker line is still visible through the welding shield because the fireworks of this exothermic reaction happen mostly beyond the plate. The top, nicely sculpted for comfort, is formed in the wheeling machine, drawing it down over the lower roller for a smooth curve. The shaped outside sections provide a template, and then the top takes over that task and the sides are shaped to fit it. A bit of to and froing is required before the edges of both can be beaten over a stake to create something more like a pressing where they will meet. At the nose, a notched bracket slips onto a couple of pins in a frame lug. I have a depth measurement for that, so making it now will help set out the seat and sides. It's a simple hacksaw, drill and file job, with right angle bends formed in the press. I'm a fanatical devotee of the man can make it philosophy. Here's some steel RSJ for the hydraulic press frame, coming back from a local recycling yard. The second bend can't quite be fully formed, so I complete it in the vise. And now we have an idea of how the nose of the seat will sit up against the tank. Now that's annoying. I was going to rattle on a bit about welding, but my video of the connection process has been misfiled. Once we reject the possibility of incompetence, it's hard to understand how this happens so often. Oh dear, I can sense your disappointment. Suppose we knock up a little demonstration piece instead. Cleanliness is also an essential to the science of welding. You'll make a messy joint on rusty steel, a weak one too. Grinding discs will remove metal lap wheels rather less of it, so get a bright surface on both sides, because the weld, properly done, will achieve full penetration and stop sniggering at the back. A magnetic clamp holds the two parts at right angles with a 1 or 2 millimeter gap. Check and adjust before you tack weld. Gas shielded metal arc, more commonly MIG welding, is a favourite for simple fabrications like this. It's quick and economical. Shielding gas for a clean spatter-free weld is an argon CO2 mixture. Remember to turn it on. I have already set the flow to about 6 litres per minute. I know that setting 3 on my welder is right for this open corner joint in 2 mm steel thickness with 0.8 mm wire. With an unknown device or task, the route is always a trial on some scrap before you lay into the job proper. Polish an area for the earth clamp and attach that. Spark up on a piece of scrap to get the gas flowing and warm the torch. Tack the ends and centre and check alignment. A few taps bring edges perfectly in line, still with that gap, and we're ready to run welds. Here, put these on, you may be able to see a bit more. I'm running welds vertically downwards, which suits me and the task. Mime the moves and hit the trigger. I pause the arc for a moment against the tack to get things flowing, and then weave an inverted V, an A without its crossbar, working down to the right, back up into my weld at the centre and down to the left a little more. Stick out, that's the distance from the weld tip to the molten wire end, is 1/2 to 3/4 of an inch, which I can increase slightly to reduce heat if things get too lively. I run to the centre tack, stop, reposition and start on the other side. A tutor asked me why I was only making short runs. I told him I couldn't hold my breath any longer than that. Just one more thing required and you'll make that perfect weld. Okay, 3 things. Practice, practice, practice. So back to the plot. Cleaning up the weld seam with a flap wheel. Mark positions for lifting loop bolts, drill and fit upside down to secure nuts for welding. At this point, the gardener rolls up to ask for water to be restored to her greenhouse. I tell her she's on telly and the water is already on. I hope someone's totting up my brownie points. With the seat in place and bolted at the rear, that front bracket can be accurately positioned, marked, clamped square and tack welded. Just tacked, because a full weld is like a marriage. I had a joke about unnecessary grinding poised there, but the censor stepped in. If all is well, weld up. And here's the finished item, bolted up to frame and inner guard. Paint, seat, foam and a cover will complete the job. And with that extra steel thickness, it should last a while, even after the cover splits.